So this is more equivalent ratios. And yes? Question? No? Okay. This is more equivalent ratios. This is going to be dealing with tables and graphs. So we're going to be able to represent our information and see what equivalent ratios are represented within a graph. So making connections between the table and a graph. Now, we're going to make 3 equivalent ratios to come up from 4/16, and we're going to use a table to help support our answer. So what's another equivalent ratio of 4 to 16? Yes? 1/4. 1 to 4. Ooh. 1 to 4, correct? Hunter? 2 to 8. That one is, the first one is dividing by 4. The second one is dividing by 2. Annabelle? You don't know? Okay, that's all right. Abby? 1 and 2, that is not an equivalent ratio because that would be not dividing both. Okay? Washburn. 8 and 32. Because what's happening is in between these, you're multiplying. I did? I haven't said it. I did that so much yesterday. Oops. It's during my other classes. The way that we're finding these is we're multiplying the left column by 4. Okay, we're multiplying the left column by 4, and since we're multiplying the left column by 4, whatever we're starting with, we have to multiply or divide for the equivalent fractions. So this one here is just like multiplying by 4, multiply by 4, multiply by 4, multiply by 4. There's a couple of you that are having trouble with that on the homework last night. Do you see how that's happening, that we're doing equivalent? Okay. Now let's graph these. I'm going to take we'll just have this be x, and this will be y. I'm going to number my y's by 2, 2, 4, 6, 8, -2, -4, -6, -8. Then I'm going to take this guy, 2, 4, 6, 8, 10. I'm going to label some of these spots. I'm going to go to 4, 6, which is right here. Then I'm going to go to 1, 4, 1, 4. Then I'm going to go to 2 and 8. Wait, something's not lining up here. Oh, I did it backwards. I did the 4, 16 wrong. That's why. How are you speaking for him? He says it's hard to see, and you say, no, it's not. Okay, there's 1, 4, 2, 8, and then... If I wanted to do 16, I can use my school that shoots straight edge, and it would be somewhere up here. And it's always going to fall on that line. It's always going to fall on that line. So 16 is going to be 4. So if I did a straight line up from 4, that's where 16 would be. Okay? That's where 16 would be.
How would you do
8 and 32, that would be straight up from here. Let's see. Do I have enough room? 8 would land. Come on. There we go. Somewhere right here. Somewhere about there. Okay? The reason I did that vertical line is just so I can line it up right. Oops. Now let's do another one. So you said it's confusing. It's okay. It was the first one that we saw. So babysitting, if Ryan charges $7 an hour to babysit, use the table to find out how much he would earn. So if he worked for 1 hour, he's making how much money? $7. So he's got $7. Then if he worked 2 hours, this ratio now, if you'll notice, is 1 to 7. So I need to find equivalent ratios. So that means for 2 hours, he's earning how much? $14. So that's how much money he makes working that many hours. That's $7 an hour. Okay? The money or the hours? No. Now, we are going to continue with this rather than have a conversation about making money. I like that you're putting it into real world, but it's not directing to this. Okay? We're not ratios, though. We're working ratios. So, no, stop. So we are going to graph this. I'm going to go with this one. I'm going to do my y is going to be, I'm going to go by, I guess I could just go by 7. So it's going to be 7, 14, 21, 28, 35, blah, blah, blah. So we're going to find another equivalent ratio from the grid that is not in our table. So we can provide that this is true by drawing a line that goes through all that plot points, and any point on that line is going to count. Any point on that line is going to count and be an equivalent fraction, because you have decimals with money, right? Yeah, we have decimals. So I'm going to go hours worked. This will be 1, 2, 3, 4, 5. So hours worked is just going to go up just like this. So that means after 2.5 hours, which would be here, it's going to fall right in this spot. And it's going to fall right in the middle of that one. What's exactly in the middle of 14 and 21? What? Toby? 17.25? 17.5. There we go. So $17.50 is earned after 2.5 hours. So we could say 2.5 to 17.5. So hours to pay. Does that make sense? We're using a graph to be able to find other parts of it. Nope. Checking your work. For every 3 laps that Anthony runs, Gina runs 9 laps. Gina is a very fast runner. Find another equivalent ratio from the grid. So we have Anthony runs 3, Gina runs 9. So can we reduce this a little bit so we can see, for those people who are struggling with it, what's happening here? Okay? Colton? Yes. It would be Gina. The laps, it's 3. Oops. I'm going to go 1 to 3, actually. 1 to 3. That's what Anthony's, the laps that Anthony, the ratio of Anthony laps to Gina laps is 1 to 3. So I can go 1 to 3, since the 1 is being multiplied by 9. The 3 needs to be multiplied by 9, which is 27. We just figured this one out, which is 3. Okay, then let's come up with another one after plotting those points. So we have a really bad graph for this, but I guess I'll go 3 here. 3. 3, 6, 9, 12, 15. So after 1 is there. After 3, 1, 2, 3 is 9. So the button on the bottom here, those are going by 1, 4, 5. The top, those are going by 3. So Jojo, do you have a question? Uh-huh. Yep, we sure do. We need to fill out that empty one. And it's going to be somewhere on this line. It's going to be somewhere on that line. Can someone tell me one that is on that line? A ratio that is on that line. Toby. So think of this ugly written number here. And then with that ugly written number. 4 to 12. So he says, let's do this. 4 to 12. I agree with you. 4 to 12. And that still keeps the equivalent ratio. And it is so warm in this classroom right now. That's all right. Well, the system was just switched to heat. That's all. So there's no more AC. Because it's only full blast 1 or full blast 2. There's no off. So here's another one, checking our work. We just need to do a couple more of these equivalent fractions. So we have words typed. We only have one of these, which is right here. So we have 6 and 360. Can that be reduced by anything?
6 times 60.
What can that be reduced by? By 6. So 1 to 60. That is the rate that we're going to do. So for every 1 minute, there are 60 words that are typed. 60. So for 2, what would it be? Yeah. 120. Beautiful. Now the other way around, though. The other way around, what's that one, Kenzie? 3. Okay. Okay. And the last but not least, Ms. Potter, what's that last 5-minute one?
I wasn't going to say that, but basically type to one letter.
Yep. Not basically. That on average it would be. Yep. Yes. 300. 300. No, that's just reinforcing your, oops. There we go. That is reinforcing your equivalent fractions. I'm going to pass out the homework now.